This is video number 2, part 2 of our Despacito modeling task. Notice, I'll just remind you that we found this article that talked about the video for Despacito that was released in 2017, and it broke several streaming records in that year. And what we got from that article was some data. They published this data that we collected here in this table, and then we used it over in the algebra section to derive an equation that fits at least the first 2 points of data, an exponential equation that fits these 2 points. So I would also like to make a nice, beautiful graph of the model. And in order to do that, I'm going to create another table over here and just use my equation to model use my equation to fill out this table, starting with day 0. And I found that at day 0, when I put 0 into my equation, I got 4.55, something around there, million views. And I can continue to use my equation to really maybe do the first, maybe I'll go by 5s here. Just for 5 days, after 10 days, after 15 days, and after 20 days. So when I can just plug in these number of days into my equation to figure out how many millions of views there were after this many days. I got about 10.76 from my model. 10.76 million views, and so on. I could do the rest of the calculations, but I want to just go over here and kind of set up the graph. And so a nice set of axes, trying to use up the space that I have here in this section. And I'm going to go to 20 days. I've got, maybe I'm going to count by 2s, because I can probably fit all 20 of my days in there. So this is 2, 4, 6, 8, 10 days, and another 2, 4, 6, 8. That's 20 days right there. These are days. So I have a nice scale and a label on my horizontal axis. I could probably get to 30 days if I wanted to, and I know that I need to scale my vertical axis for the number of views, and I didn't fill out my whole table here, but I can see that I'm kind of expecting this thing to get up to about 200 million after about 20 days. So if I go up to 200, maybe here, let's see if that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if I count by 10s, I'll just get to 100. So maybe I am counting by 10s, because this will be 0, and then 10, 20, 30, 40, 60, 80, 100, and so on. All right. So 200 million, and those are the views. I'll say millions of views. So I labeled that axis. And now I can just get to plotting. Somewhere about here is my initial condition. And after 5 days, which is here, I get up to about right here. And I should see a pattern emerge that looks very much like an exponential, but I didn't want to do all the work for you. So make sure that you have a nice, beautiful exponential graph here once you're done, and then you can move into this section right here. And our our slideshow offers a couple of questions to consider right here. And first of all, we want to determine how good our model is. So the first thing we do is we're going to say, according to my algebraic model, which is just our equation. According to our algebraic model, how many views do we expect? I expect a certain number of millions of views after 154 days. The reason I want to do this calculation with my equation is because we used these first two data points to create our equation. So I would certainly expect that if I put 1 into my equation, I'll get 5.4. And if I put 22 into my equation, then I'll get 200. But now I'm going to test how closely my model predicts what happens at day 154. So when you plug 154 into your equation, how close to 2,000 millions do you get? And that's really what that question is about. And then, based on the information from again, this document, we have some other information that we came up with. We determined, we kind of analyzed what the multiplier is in terms of a percent increase. And so you can take this relationship and go backwards to figure out what the daily growth rate of this video was during this time when it went viral. So we'll also try to think about that. We're going to use the multiplier, using the multiplier that we came up with, b, that is, in our exponential equation. The daily growth rate of video views was what? What did you determine the percent growth rate every day of this was? And then finally, consider completing this statement, right? This is it a good or a bad model? Good, bad model, because ... You're going to complete that statement by thinking about how closely did our model predict the growth rate after 154 views? And then also thinking about, like, can we apply this model to other videos to figure out if they're going to go viral or not? Maybe we want to know that. Maybe we want to make that prediction. We might be able to, good predictions can often be worth money. And it's very important in making decisions to make good predictions. And that's what we want to understand. Is our simple exponential model that we came up with over here, is that going to help us predict if other videos will go viral?